Now, your note guide, flip it to the side that has this table that looks like this. Mine is in color, yours in black and white. Flip it to that side. You see it as a table. So everybody have that in front of them with a blank sheet of paper. So flip it to this side. Okay? So just have that in front of you because I'm going to come back to this right now. It's very important. You have no clue what this means. But I'm going to come back to this. You're going to have a clue after I show you this example. Watch. So, title, special right triangles. With me, go ahead and draw a right triangle, but make sure the legs are the same size. Look at this leg and this leg look the same size, and then I'm going to draw a hypotenuse. Do that with me, please, and make this a right angle, please. Do that. But make sure your picture has the legs being like kind of the same size. Okay? You with me? Nice. So far, so good. Now, if the legs are the same size, that means the angles in here have to be 45 degrees. Have to be. It's just like a law of reality. It's just the nature of reality. Okay? So we got a 45-degree angle here, that acute angle, and a 45-degree angle. This is 90 degrees. If you add them all up, they equal 180. We already know that from about a month and a half ago. All the angles of the triangle have to be 180. Now, the legs are the same size. Let's pretend they're vast. What's your favorite number? Let's say this is 7 inches here, and this is 7 inches. Do that with me. Then that means the hypotenuse is going to have to be, it's going to have to be 7 rad 2. Do that for me. Why? It's just the nature of reality. It's like asking, why does gravity make things fall? It's just the way it is. So it's really, I'm not even trying to be funny. My point is this: whenever you have two 45-degree angles inside a right triangle, then the legs will always be the same size, and the hypotenuse will always be the leg times rad 2. Always. It's just some freaky factoid, fun fact of reality. Now, going to draw the same triangle but bigger. The leg is the same, leg is the same. Look at it, but bigger. Do that with me on your notes. Give me the right angle. So I just increase the size.
So there's different types of special right triangles.
Right, there's 2 of them.
Yeah,
30, 60, 90, huh?
yeah, 30, 60, 90.
That's where we're going to get there now. Hang tight. Stay with me. I love that. So the legs on the smaller one was Mrs. Bass's favorite number. I'm going to increase it to, let's say, 10. I'm going to write 10 here. That means this is going to be 10. What will the hypotenuse then be? 10 rad 2. You guys start seeing this. Look at this. This is 45 degrees. This is 45 degrees. Okay. Watch this. What would be the tangent of 45 here? So write this underneath the first triangle. What would be the tangent of 45? Let's see. Sokotoa. Opposite over is the opposite over adjacent. Let's see. Here's 45. It doesn't matter what 45 you use. You want to use that one or that one? Take your pick. Knock yourself out. Doesn't matter. You're going to get the same answer. What's opposite of 45?
7.
Thank you. What's adjacent to 45? So what does that become?
1.
Thank you. Let's do this. Let's do the tangent of 45 over here. The big one. Opposite of 45? Adjacent equals 1. So here's a moral of the story, you guys. No matter how big or small the triangle is, let's say I make it a lot bigger. Maybe not. A lot bigger, a lot smaller. Doesn't matter. Look at how the 45s never change, the angles never change. The tangent will always be 1. Not only that, watch this. Doesn't end there. The fun doesn't stop. Look at the table now in front of you. I just did this case. Look at 45 degrees. The tangent will always be 1 forever, ever, ever, ever into eternity. The sine of 45 will always be rad 2 over 2 forever. The cosine of 45 will be that. The tangent will always be that, always be that, always be that, always be that. No matter how big or small the triangle is. So these are called special angles. Think of the title you just wrote down. They're called special right triangles. They're special. Are you special? We're talking about, sorry for the curveball. We're talking about triangles that are special. And they have these angles. Check it out. 30 degrees, 45 degrees, or 60 degrees. And Gomez was already anticipating the next one now. Watch. So underneath these two, this time draw a right triangle with me where one leg is bigger than the other. So make this a small one and make this one the bigger leg. And then draw a hypotenuse with me. Do that with me. So this time the legs aren't the same. One's bigger, one's smaller. Do that with me. Go. Let's pretend that this is 60 degrees. Let's pretend this is 30 degrees. We've got a special right triangle now. Lopez, what's your favorite number? So let's pretend the small leg. There's two legs here. One's bigger, one's smaller. And you got the hypotenuse. Let's pretend the small leg is 5. Do that with me. That means the longer leg is going to be 5 times rad 3, and the hypotenuse will always forever be 2 times the length of the smaller leg. It's going to be 10. Always. It's just the nature of reality. Could you make a square circle? Thank you. You should have. That means she's thinking. She's thinking. If you put what? That means you're really thinking. Could you make a square circle?
You could put it a circle.
A square circle?
True, but can you make a square circle? What would a square circle look like?
Square.
Yeah, mostly a square with like.
So, I'm giving you a logical absurdity. In philosophy, I just mentioned a logical absurdity. It's like saying, I can't speak a word of English. Think about that. I just did speak a word of English, right? It's a logical absurdity. So, in the same way, if you have a 30, 60, 90 triangle, whatever this leg is, the hypotenuse will always be twice as big. If this is 5, that's going to be 10. If this was 20, that would have been 40. 50, that would have been 100. It's just the way it is. It's just the way it is. You want to ask why? Knock yourself out. It's just the way it is. Let's go and draw a bigger one now. Same thing, but draw it bigger. One leg's bigger than the other one. No? I lost you?
You lost me because at the other triangles, you put 7 rad 2 for the hypotenuse.
Yeah.
Right, but that's a different angle, huh? Is it not? That's 45, 45, 90.
Oh.
Good. I like how you're thinking. Good. So that's for 45. Now, this is for a different special right triangle. Okay? It's another kind of special right
So the
triangle.
hypotenuse is usually the 30.
One more time. Say that again.
Is 30 usually the hypotenuse?
Well, 30 degrees, the hypotenuse is the side. You're talking about an angle. Don't confuse the two. The angle is the space. The hypotenuse is a side that's always the longest of the triangle. Okay? This was Lopez's favorite number. Let's say I increased it to 10, which I did. This is still 90 degrees. This is still 30, actually 60 rather. This is 60 degrees, this is 30 degrees. What would the longer leg be then? 10 rad 3. And what would the hypotenuse be? Thank you. You guys see it? I trust. No matter how big or small. One more time?
Usually multiplied by
Right. The shorter leg's always going to be twice for the hypotenuse.
Another question. Where did you get the round 3 from?
It's just the nature of reality.
Okay.
It's like square circle kind of thing. If this is 30, this is 30 and 60 and 90, this is always going to be the case. Matter of fact, if you can give me a case where this is not the case, you're going to be world famous. Right? You know my challenges. It's just logic, man. It's just logic. Here we go. Let's go ahead and write sine. What the heck happened there? Sine of 30. Do that with me. Sine of 30 degrees. So the sine of 30 degrees is C. Thank you, Gomez. Opposite of hypotenuse. So opposite of 30, 5 over 10, that becomes what? 1/2 on. Let's do the big one. Sine of 30 over here. In this case, it's going to be 10 over 20. It's going to be 1/2. Look at your table. Look at this. Look at the table next to you. The table of info, and look at sine of 30 degrees, and you're going to see it's going to be 1/2. Always. In other words, we covered this one. Sine of 30 is right here. Boom. Always 1/2. That's notes. Tell you they're short. We're going to dive into more on Monday.